Please meet our next speaker, True Insight Lab CEO, Kamilė Butkevičiūtė.
What if we can hack the human mind? What if everyone in this room can be a part of common consciousness, where knowledge would be absolute and skills can be transferred from one person to another within the matter of seconds? Is it fascinating or scary? What do you think? Both. Okay, so let's do the hand-raising thing. Who thinks that it's fascinating? And who thinks it's very, very creepy? Okay, I get what you mean. Okay, so let me calm the ones that think that it's very creepy, because as much as Elon Musk and Neuralink would like, merging human and machine is still very far away in the future. But the situation I just described is very real. But it's actually a scenario of sci-fi movie called Mind Games. But what really triggered my interest about this movie, despite its horrific IMDb rating, was the experiment that they did in US a little while ago. They gathered 1,000 volunteers for a special VIP screening. Within this screening, they hooked up people to the EEG devices, pretty similar to the one I'm wearing right now. And these devices are meant to monitor persons' brainwave activities. And they monitor persons' and viewers' brainwave activities while they were watching a movie. And they donated these unique data sets to researchers all over the world who are tackling and who are working with this field. And of course, what consumers and what viewers got from it, they got to see, and sadly it's not released, so I can't share it with you, but they got to see the first of its kind common consciousness map. Hi, as I said, I'm Kamilė. I'm a founder and CEO of True Insight Lab, and today I'm going to take you through the journey of bio and neuro sensors. And I wanted to start my talk in saying that this topic is so broad that literally I can speak for a month with you. Sadly today, I have just 30 minutes. And I know that this topic is spiking your interest, and I know you have a lot of questions about it. So I will try my best to keep my presentation short and to allow you to ask your questions. So let's start the journey. A first neuro sensor I would like to talk about is electroencephalographer. And I'm wearing a very simplified version of the scientifically used EEG device. What it is, it's actually a set of electrodes that are attached to your scalp. And those electrodes enable to measure and monitor your brainwave activity. How it does it? It's actually quite simple. It just monitors electrical reactions that are happening because of your neurons communicating with each other. And there are a lot of huffs and puffs about mind reading and being able to hack your mind or affect your mind. And I want to make it clear that this device is a monitoring device only. And it can say what is happening in your brain, but it can in no way affect it. So let's talk about the more real-life application on this technology. So after certain calculations done, you would be able to monitor how active is your mind and in what mind state you are. This is very crucial, for example, being focused when you're doing very important things, such as driving or piloting a plane. Also, it can benefit you as a user, as a person who would like to be engaged in the surrounding, because it's also able to monitor your engagement into content and to the things that you hear in conferences or in school or in universities. One very interesting and very admirable, I would say, startup and now quite a big company from Canada, Interaxon, released first of its kind EEG device that can actually improve your meditation. It monitors your brainwave activity during your meditation session, and it provides you information on whenever your mind is wandering around somewhere and you need to go back. It provides it with a sound feedback, so if you're doing your meditation, but you're still thinking about that last email I haven't sent before I went on my weekend, then you would hear a wind, indicating that you are somewhere and your mind is not calm. And if you're calm and if you're doing your meditation really well, you hear waves. Personally, I have this device and I tested it, and it's a challenge at first, but after a while, it can really improve your meditation sessions. Also, EEG devices are used in consumer behavioral research. It enables researchers to get a glimpse of how engaged people are in a certain content, whenever it's a video or an educational piece. And although the technology and the application in research is very promising, us in the lab, we always say that we know still so little about how our brains work that we need to be critical here. And we always advise, if we are using EEG devices for your research, that's great, but please share and use other sensors as well. Just double check the data, double check the insights that you get. And remember I said that we know about the brain so little. Raise your hands, who knows the theory called consciousness theory, where researchers say that our minds is divided in sections. And for example, one section is responsible for visual attention, and another section is responsible for the way we feel. Just raise a hand who is familiar with it. Okay, so it's, in this field, it's the most common theory that every scientist used since 2007, when it really got questioned by one of the cases. It was a 44-year-old guy who walked into the hospital with leg pain. He just felt weakness in his leg. And researchers and doctors were stunned because they put the guy into a fMRI machine and they saw this. 90% of his brain mass was missing. But he was alive. He wasn't just alive, he was walking, talking, and leading a normal life. And although his IQ was significantly lower, but he was working, he had a family, he had 2 kids. This got researchers thinking, really, how much we know about human brain. And of course, at 2017 in January, a few of the researchers tried to question this case, because they said it was just a case of this severe swelling and severe liquid concentration in the brain, but actually the brain mass is still here. So it's still a question mark, but it actually shows very well of how little, significantly little we know about the way our minds work. So let's get back a bit from neurotechnology to more everyday-like sensors that we all use and we all know. A biosensor technology became mainstream when first wearable devices went into the market. And first wearable devices were able to monitor our movements, how many steps we take, how many kilometers did we run. And at first it was so fun to know how many kilometers have you ran, or to see the map of the strange shape that you did in between your night's run. But actually a worrying trend emerged within the wearable device industry is that although people were buying the devices, 30% of them stopped using them within a span of 6 months. And when you get digging into it, it's actually quite understandable because you have a lot of information, a lot of data about your workouts, about your training sessions, about your running. But the question arises, so now what? So I know that I ran 5 kilometers more today. What I really want to know as a woman who does sports, how I can be better, how can I run faster, how can I beat myself? And I really liked the BTL stunt that Nike did recently. They challenged people. They challenged people to run against themselves. What they did, they built an LED screen-empowered racing ring where a person ran first lap, and at the second lap, he was joined with a ghost of himself. That was a time of his first lap. And actually, you can challenge yourself. That's what I call kicking your own ass. Also, I'm proud to be a part of one startup from Lithuania, OVAO, smart swimming company. And what we want to deliver to swimmers all over the world, and we hope that we can deliver that promise to sports people in any other sports, personal instant coaching. And the way we do it, we provide instant feedback on workout intensity levels. And when you swim, you instantly know whenever you need to slow down and speed up. And that's the trend that I see in all wearable devices. Move, Fitbit, all major players are moving past monitoring towards insights, towards life coaching. Biosensors are very common to us. And I would say, how many of you have wearable devices or certain bracelets that you monitor your workouts with? Please raise your hands. Okay, so maybe 25% of all users. But further on, I wanted to speak of the less mainstream technology, but also very promising. Eye tracking is technology that enables computer to see exactly where you're looking. And it brings a lot of promise and a lot of possibilities to various fields. Few of them I will talk about today. The first field is games. Gamers are fed up with the interactive devices. It's not enough to have a keyboard or a joystick to be able to be a part of the game. What they really want, they want real-life experience. And that's what eye tracking is bringing them. Because with the integration of eye tracking to your computer or to your console, you're able to be a part of the gaming experience more. For example, you can look around. As in any other room that you're walking, you can look around natively in a game. If you are looking at the person or you're looking at your enemy, the person reacts. And of course, if you're playing a scary game, you better run or shoot. I don't know, I'm not a gamer. But I know the gamers are really excited about the technology. And it goes not just to PC gaming, it goes into VR gaming as well. Because major players as HTC are introducing, I think it was 2 weeks ago, HTC introduced the add-on to the HTC Vive and plug-and-play eye tracking solution that enables to empower HTC Vive with eye tracking possibilities. And another field that the eye tracking is also used in is research. And the biggest players in the market and the movie makers from Hollywood already use this technology to craft ever-engaging stories. With this technology, creators are able to put their theories to the test. And with this technology, we are able to be a part of more engaging and more native stories. Of course, these technologies also used for brands and for marketing and for usability. Do you know the feeling when you go into the website and you really want to find a piece of information that is surprisingly not there? That's what I call a bad usability example. And eye tracking is able to empower usability tests in a way that was never done before, because it can track instantly how a person's visual attention shifts from one part of the site to another, and then enables designers and usability experts to build ever-engaging websites. Also, as I mentioned, it can be used in communication and bringing your message to your customer. I really liked the piece that Canadian company did, and what they did, they provided users with a game where they can choose the card. And surprisingly to them, a billboard revealed the same card that user chose. And for user perspective, it looks magical. But what it really is the integration of video camera and eye tracking that is enabling to deliver this experience. And it's just one of the many examples of how eye tracking can be used in better interactions with users. And also I want to share with you one of the social examples, since I'm also I'm a cause marketer. I love to do communication campaigns that actually changes something. And what I really loved about this example is that interactive billboard was installed in the major squares of one of the cities, one of the European cities, and it talked about a very painful society problem, violence in our families. And why violence in families are there? Because no one is talking about it, especially victims. But from the society point of view, if society will reflect how negative it is, we together as a nation can tackle this problem. So what they did, they placed a video camera and eye tracking devices into the billboards with a powerful message: look at me. And the image was a woman who was beaten. And the more people looked at women, the healthier she got. And the message was, domestic violence will stop when each and every person will pay attention to it. And again, this is technology piece that empowering, at this point, non-for-profit organization to spread their message. I want to talk more also today about the possible future of sensor technology. And all of the sensors that I talked today, brainwave activity tracker, eye tracking devices, biosensors, they can all be more engaging and more connected to you. And of course, in one way, as we talked at the very beginning, it's fascinating, and as well, it's scary. But the thing is that we don't stop as well. As technology progresses, we as human beings also progress. Our ethics progress, our laws progress, and we can be a part of an ever-engaging future, but still be ourselves and live with a sync with technology, not against it. And two of the examples I will share today, one of us is facial emotion recognition. I will not bother you with technical details, but what it is, it's actually a web camera that scans your face, and machine learning algorithms identifies what out of 6 major emotions are you feeling. Are you happy? Are you frowning? Are you sad? And for us humans, it's very basic to feel what emotion we are feeling and what emotions you're feeling. Like, you all know that I'm stressed a bit and I'm happy a bit to be here, to be talking with you. But for computers and for robots, it's mission impossible. And what facial emotion recognition offers to them is a better connection with human. Can you imagine your iPhone sensing that you had a very bad day and trying to make a joke? Or trying to play a song that you love? And more human-like robots will go to our home and to our workplaces. And of course, they, in no level, can feel the emotional connections or feel the emotions that we're feeling, because it's the obligatory of human. But what they can do, they can be a better assistants, they can be better colleagues, they can be better assistants to our children as well. So I wanted to share with you one very positive example about education. Meet Tega. Tega is a robot who teaches children Spanish. And what is it unique about Tega? That he not only provides you with the certain tests that you need to do, but it also reacts to feelings that you feel. So if children get the exercise and he's really confused, he's thinking hard, he doesn't know what to do, Tega reacts to it and asks, hey, I see that you don't understand it a bit. Maybe you need more explanation. And what really fascinates me, that children are treating Tega the way they would treat a normal human being. And the promise here is that all nations that are struggle to have a proper education would be able to have Yale professors or perfect teachers to their children just because of the technology. And I talked a lot today about consumer behavioral research. And of course, since I'm a part of lab, it's just one thing that it's always twisting in my mind. So one thing that we were working on right now, and we started a little less than 7 months ago, together with my colleague Eva, is that we're working on first of its kind visual attention prediction algorithm. And I'm sorry that my colleague Eva can't be here with us today. She is now in Netherlands. Hi Eva, hope you're watching. It's a brainchild of hers. She is a developer and a very bright person, and she believes that deep learning and artificial intelligence can actually make a difference. And what visual attention prediction algorithm is, it's, as I mentioned, deep learning algorithms that is able to identify visual attention changes within people without them being in a room. How it works? It's very simple. You upload the video piece that you want to test. You choose gender, ethnicity, and other parameters about your target audience, and then you instantly get the prediction of the possible visual attention patterns within the matter of minutes. And within the lab, of course, it's very early. And we're looking for partners, we're looking for researchers, people who can provide us with training data sets for the algorithm, and interesting people who would like to see this algorithm live in their applications. And this is the future I see for research as well, because now what we have questionnaires that are, although very useful, but non-sufficient enough to predict how people or users will react and behave. And what visual attention prediction algorithms offers to us, it offers to us a gap, to bridge the gap in between us and Generation Z. Because our attention patterns are very, very different from the ones that 15-year-olds now experience. They are very ever engaging in multiple screens. Their attention shifts in a second, and imagine how it affects and redefines education. Our education system is not suitable for them just because of that. So what visual attention prediction algorithm here can do, it can actually help educators adapt their content and adapt their curriculums to our Generation Z. So today I talked a lot about technology, about the way it shapes our reality, our everyday lives, our research, but I want to leave you with one thought. Don't be afraid of technology, and don't be afraid of changes, because they will still happen anyway. And what you can do, you can be a part of them, and you can use them in your everyday life, in your work, in becoming a better human. Thank you. So I initially left some time, hopefully, to you guys to ask your questions. So since we're being live streamed, I would ask to raise your hand and wait for the assistants to bring the mics in. So who has any questions about the theme? Okay, so I will leave you with the thinking part, and if you want, please feel free to approach me after the talk. Thank you.